Hey there, people. In this video, I'm going to be talking you through the answer key for the week 4. And this one's going to be dealing all with rational expressions. This should be the freshest in your brain. Well, no, second freshest. This and radicals, right? Because that's really all we've been doing so far this semester before the whole coronavirus thing took over. So this was what we started the semester off with: simplifying, multiplying, dividing. We're not going to do any graphing with this week's problem set, but we will do some adding, subtracting, and solving, and that's where a lot of people had some issues. So first, let's go ahead and find our excluded values. So these are values that are not in the domain. Those are just excluded values. We look in the bottom of our expression to find those. So first and foremost, I factored out the bottom. Difference of squares gives me conjugate pairs. Once I have those, I know that I cannot use, excuse me, I cannot use 9 or negative 9 because then I'd get a 0 in the bottom and I can't have a 0 in my denominator. Questions 2, 3, and 4 are all simplifying problems. So when you simplify, you factor out the top, you factor out the bottom, and see if anything cancels. So up top, I've got a GCF of 2. And now I'm noticing, hey, v squared minus 49, that's difference of squares. Difference of squares gives me conjugate pairs. So I continue to simplify and factor. V squared minus 49 is v plus 7, v minus 7. And now I've got canceling terms. I'm left with 2 times the quantity v minus 7 all over v minus 1. You'll notice the parentheses are no longer there. You can have them if you want to. It's not mandatory. But if that's my one and only factor in the bottom, I don't need it. All right, number 3, same process. GCF up top. Ooh, difference of squares yet again. So we factor out as far as we possibly can go and find terms that'll cancel. One from the top, one from the bottom. You know the drill. Number 4, GCF from the top is 3. Once we have our GCF out, we factor as far as we can possibly go. So w squared minus 8w plus 7 factors down into w minus 7, w minus 1. Again, numbers that multiply to be positive 7 but add up to a negative 8. And then from there, we cancel out any terms we can. And here is what we're left with. All right. Number 5. This is going to be the same process. It just looks a little bit more gross. We're going to still factor out the top. So I'm going to factor out a GCF. Now what I can do here is this 4 is technically a factor, and same with the 8. Since they're not directly touching a plus or minus sign, meaning that they would be individual terms, they're actually being multiplied, I'm allowed to have those interact with each other and cancel down. So 4 over 8 as a fraction, that's 1/2. Then I've got the v's. I've got 3 up top, 6 down below. I could cancel out 3 from each. So the v's are just gone in the top, and I'd have 3 left over in the bottom. It's not written, but technically, like I said, this 4 turned into a 1. So if you really wanted to put a 1 outside of the parentheses, go for it, but it's not going to do anything. All right, question numbers 6 and 7. Here we're going to factor out as far as we can. So I need to factor out the top and the bottom of this first fraction. Oop, and the bottom of the second fraction. Looks like I got a GCF there. Once we have that, we're going to see if any term from either numerator can cancel out with any term from either denominator. Basically, anything from the top can cancel with anything from the bottom as long as the factors match. All right, so here's the factoring of the first ratio. And then the second one, I just factored a GCF of 4. And then we can go ahead and cancel. When we cancel these, like I said, anything from the top. So an x minus 3 here can cancel out with an x minus 3 there. X minus 1, x minus 1. And then that's what we have left over. Number 7 is the exact same concept. Factor out as far as you possibly can first, and then look for terms to simplify. Here we've got an x minus 3 and an x minus 3 that cancel, and that's about it. So here's what we'd be left with. 3 times the quantity x minus 2 all over x minus 1, x plus 3. Questions 8 and 9. They're going to be the exact same as 6 and 7. The only difference is now I have division instead of multiplication. Well, division behaves the same way. All you have to do, and I drew a little arrow there. Let's see if I can draw one on the trackpad. Woof. Is you are going to flip-flop the second fraction, and then it just becomes a multiplication problem because dividing is technically multiplying by the reciprocal. So for both 8 and 9, you'll notice that second fraction got flipped upside down. The first fraction did not get touched. And then we follow our same multiplication rules where we look for terms up top and down below to cancel out. Onward. Now we're going to start getting a little bit more difficult here. We're going to do some adding, subtracting, and solving. For each one of these, you have to find the least common denominator. But here my denominators are 12b3c and 8c3k. I want to figure out what denominator would make both of these two happy. Basically, what can I turn both of these denominators into so that they would match? And I'm only using multiplication. Easy way to do that, start off by numbers. 12 and 8, those both go into 24. I could multiply 12 by 2 and 8 by 3. And then my first fraction says I need to have 3 b's and a c. I can have more stuff beyond that, but as long as I have 3 b's and a c, we're good to go. The second fraction says I need to have 3 c's and a k. I can have other stuff on top of that, but as long as I have 3 c's and a k, we're good to go. So the denominator that would make both fractions happy would be 24b3c3k. Remember, this first fraction says we need 3 b's and a c. I've got 3 b's here, and I've got more than 1 c, but as long as I have at least 1 c, we're good. Here I've got a multiple of 8, yeah, 24. I need 3 c's, check, and a k, good. Once we have that, you need to figure out what is each denominator missing, and you're going to multiply that to the top and bottom of that fraction. So to turn a 12b3c into this common denominator, I would need to multiply by 2c squared k. Whatever I do to the bottom, have to do to the top. Same thing over here. To turn an 8c3k into 24b3c3k, I'd multiply both top and bottom by 3b cubed. And then all this is just multiplying the numerators and cleaning things up and writing this as one big fraction. Number 11, same exact concept. Figure out what is our common denominator between a 12 and a 9. And then we have d squared k squared and 8 to the third k to the third. So our common denominator is listed right up here. And what do I have to do to each fraction in order to result in 36 a to the third d squared k to the third? So that's where these values that I'm highlighting off to the side are coming from. All right, number 12 is going to be the exact same. Finding the common denominator, adjusting the numerators accordingly, and cleaning everything up as best you can. Number 13 is a division problem, but it's written as a fraction. So I essentially interpreted this as just a simplifying problem because that's really what a fraction is, right? It's just division. So when I did that, I figured out, okay, the top has a GCF of 3x to the third. And now I've got the 3's cancel, the x's cancel, right? All of them cancel, 3x to the third. So I'm only left with 7x cubed minus 3. So that one's not too scary. Number 14, solving for x. Well, what I can do is take this x plus 3. If I wanted to get that out of the denominator, I can just multiply that to the other side. Right? That's mathematically legal. And then we would distribute in. And then from there, just solve for x. That's an algebra 1 equation right there. All right, now solving equations where there's multiple denominators. Let me first start by saying that 15, 16, and 17 are all the same. 18 and 19 are both the same as each other. I'll talk you through 15, and then I'll just reveal the answers for 16, 17. Same thing, I'll talk you through 18, and then we're not even going to do 19 because it's the same thing. All right, so first thing you want to do on question 15 is factor out. So I'm noticing the bottom here would factor out into 5 times quantity v minus 3. Once everything is factored, that'll allow you to find your least common denominator. So that's your goal. So we need to have common denominators here. Now, clearly, not everything has a 5 times a quantity v minus 3. The first fraction, well, it already had the v minus 3 term, but it was missing a 5. So I just multiply 5 to top and bottom there. The fraction with the 7 up top, that was totally fine. I didn't need to do anything there. And then the fraction at the end, the 1, which is technically 1 over 1, it was missing both the 5 and the v minus 3, so I had to multiply both of those into there. Once you have that, all of the denominators, right, they all have the exact same components. They have a v minus 3 and they have a 5. Once we have everything all over the same denominator, oh, that's gross, I'm sorry. Let's see if I can clean that up. We're going to solve the equation that is created by the numerators. So that'd be negative 40 equals 7 plus 5v minus 15. So that's the equation that we're going to solve. Again, as soon as you get to this part, it's just algebra 1. 16 and 17, exact same concept. Factor out first, figure out what your least common denominator is, and go term by term. What is my denominator missing? I'll have to multiply that to both top and bottom. Once you've done that, you take the equation created by your numerators and you solve from there. Let me show you 17 here. One other thing I should make note of is right here, whenever there's a negative sign out front, you'll notice I always put it just straight to the numerator. I find that that helps me keep track of the terms as I go through. All right, so now to problem 18. Problem 18 is kind of gross. So gross, in fact, that I goofed. Ugh. Icky, icky, icky. So first thing we need to do is factor out, and this one's already factored. Cool, cool. I'm noticing my common denominator has to have actually two separate components to it. It needs to have a u plus 1 and a u plus 2. Well, the first fraction already had a u plus 1, but is missing a u plus 2, so I'll have to distribute that in there. My middle fraction was actually missing both pieces. It was missing a u plus 2, and it was also missing the u plus 1. So it was missing everything. So this middle term right here, that's actually going to result in a squared piece that I have to be ready to handle. The last fraction, it already had a u plus 2, but it was missing a u plus 1. So once we go through and get all of that set up, I'm going to take a look at just the equation created by the numerators, because now all of my denominators match. So this is what I would get right here. 2 times u plus 2, I can distribute that in, 2u plus 4. Negative 6 times these two binomials multiplied together. Well, I decided to multiply those together first, and then I'll distribute the 6 in there later. And then 1 times u plus 1, well, that's easy, right? Distributing 1 doesn't really do anything. Once we have that, I'm going to go ahead and just clean up the right-hand side a little bit. So I distribute in the negative 6 onto every single term in there, and that's where these values come from. And then we like to have these set equal to 0 if we're ever trying to solve something that has an x squared, or in this case, a u squared. So I'm going to move everything over to one side of the equation, so that way I can set it equal to 0. So as I move everything over to one side, this is what it'll look like. 6u squared plus 19u plus 15. I prefer to have a positive u squared term, so I moved everything over to the left. And then we can go through and factor. Once it's factored, we can solve. And as promised, we are going to skip 19. So this one is, no questions asked, the hardest problem on this whole problem set. Same thing with 19 because they're the same type. So please don't get frustrated if this single problem takes you like 3 to 5 to 7 minutes. That's not uncommon. All right, you know the drill, folks. If you have a question, please let me know. Good luck, have fun, be safe, roll tide.